Descriptive statistics, and on the screen it says input system output, and you may think that you've gotten on the wrong video. But what I want to do is to make some points here in terms of one of the more important uses of descriptive statistics. So we're going to look at this idea of the input being the customer arriving, the system being your business, and the output being the customer that is leaving. And got a little start here, and we have what's written down is feeder population. And in statistics, often it is just called the population. But what we would like you to recognize is that out of this population comes the customer. And the customer is the input. They are arriving at your business. They want some service. Now, there are two random variables that you want to keep track of when you're dealing with your customer. One would be the needs of the customer are random variables. Customers have different needs, what they want. Another random variable that you want to keep track of would be the arrival time or the arrival patterns. Second random variable. Feeder population, you also tend to look at the demographics, and this is a wonderful use of descriptive statistics. Then we have your business, which is your system. That has a tremendous number of random variables in it. We aren't going to talk about those in this particular video, but lots of things. So businesses, your system is made up of humans, and I don't think there's anything that has more randomness to it than a human. The customer, when they leave, there are two other random variables that we would like you to keep track of. One would be the satisfaction level. I'll abbreviate that. Satisfaction level. That's a random variable. How loyal will these people be? They will move back and go into the feeder population, and they talk to other people, and this satisfaction level can cause this feeder population to shrink or to grow. The other random variable would be the profit dollars that customer has generated for you. That's a random variable. And now with the computer and all the technology, we're able to frequently keep much better track of this. Some of you may have worked with activities-based costing, being able to really understand what our profits are. We've got a little problem here that we want to start talking about in terms of random variables and descriptive statistics. And we're going to say the feeder population deals with people who have a service contract with us, and they arrive and they want service. And we have what's happened in the past. One of them's cost us $12, $1, $40, $3, $5, $1, and $8. That's our population. Now, if we're going to go off and look at the past, we have to make this judgment call. And there really is nothing, in my mind, more important than this judgment. Before you begin thinking about using statistics, you have to say to yourself, are the patterns of the past going to be the patterns of the future? And if the answer is no, we have no justification for going on and doing a statistical study or looking at a census. If the answer is yes, then we can go off and say, it makes sense for us to gather data, measurements, evidence. We use those all synonymously. So for this particular problem, we're going to say we believe what it has cost in the past will be the cost of the future. So we're going to look at how people have behaved in the past. When we do this, we have really basically said that inductive reasoning is a legitimate process. When we work with data, we can have all the data, none of the data, or some of the data to create our information. If we have all of the data, we use the phrase census. And if we have some of the data, we use the word sample. When we have all the data, frequently this is called decision making with certainty and is studied in areas called applied mathematics. When we have some of the data, we have a sample. This is called decision making under risk, also known as statistics. Now, if we look at this particular problem, we could have all of the data. We could have taken a census, and then we have what are called parameters. The true average, the Greek letter mu is used for the true average. We add up all the x's. We have 12, 15, 16, 56, 57, 62, 70. We add those up. We had 1, 2, 3, 4, 5, 6, 7. And the true average is 10. Now the median is the middle value of an array. And so we would come back and we would rearrange these in ascending or descending order. So we've created an array, and the definition of the median is it's the middle value of an array. So the median is equal to 5. Now notice that I don't have a special symbol as I did here for the true average. The Greek letter M, which would correspond to the mean, the Greek M, stands for the true average. When we have a census, in statistics, we will always use Greek letters. Now, when there is not a special symbol for each particular concept that we're defining, it basically indicates that this is not a particularly important statistic or particularly important parameter. In this situation, we have looked at everything. We have the truth. And these are called parameters when the result is based on a census. The mode is the most frequently occurring value. There may be no mode. There may be more than one mode. In this particular example, the mode is 1. So these are called parameters. Again, a parameter is any result that is based on a census. Now, if we take a sample, we might have taken the sample, and if you remember our population had this. We might have gone in, randomly selected these 3 values. By looking at a sample, we hope to be able to indicate what is true of the population. We have a sample. We add these up. They add up to 9. 1, 2, 3. The small letter n is used to indicate the sample size. The bar indicates that we have a sample average. Sample average is 3. The median, in this case, would be 3, and the mode would equal none. These are called statistics. A statistic is any result that we get that is based on a sample. Now, if we take another sample, if we had taken a different sample, we might have gotten different values. We might have come back and we might have picked the 5, the 8, and the 12 this time. 5, 8, and 12, a different sample. We then get a different set of numbers. So we get 25 when this is added up. The sample average is 8 1/3. The median is equal to 8. Middle value, and again, there is no mode. These are also statistics. And so what you want to recognize is that statistics estimate parameters. And in particular, X bar will be a statistic that we see a lot, the sample average or sample mean, and that is an estimate of the true average or true mean. Now, if we look at the particular example that we had, we can go back and we can see that we had a sample average of 3, and we had a sample average of 8 1/3. The true average was equal to 7. Similarly, we had a median that was 3, and we had a median that was 5. The true median was 5. The mode, we kept coming up with no mode, and yet the truth was 1. Estimates are called statistics. Truths are called parameters. You want to have those definitions clearly memorized. And so, in ending here, the other thing you want to recognize is that all statistics are random variables, which means that when you take another sample, the statistic that you will get will vary or be different. Hope this is helping.